8.4 says the line g of x is equals to ax plus b is a tangent to f at the point of intersection of f. Determine the equation of g. So we're looking for the tangent to f at f's point of inflection. Remember, the point of inflection is where the concativity changes, which should be somewhere around here. So to find that point, we need the second derivative. Now, using our first derivative, we can get our second derivative as minus 6x plus 12. Let's shift this over to the side. Cool. So now that we have our second derivative, we know that when our second derivative is equal to 0, that's the point of inflection. So minus 6x plus 12 is equal to 0. If we solve for x by taking 12 to the other side and dividing by minus 6, we get point of inflection as 2, which is that point there. Therefore, we can use this x value of 2 to find the tangent to the graph at that point 2. And in order to do so, we are going to use the following first derivative in order to figure out what the gradient is of the graph at 2. So what is the gradient at that point? So in order to figure that out, we need the first derivative. So the first derivative was minus 3, x being 2 squared plus 12 times x, which is 2, minus 9. Doing all of this gives us a value of gradient of 3. So our gradient is 3 and our x value is 2. So what is our y value at that point? Because that's the only thing that's missing. We know our x value at that point. So what is our y value at that point? Now, to get our y value, we simply put 2 back into our original equation. And by doing so, we get so f of the original function. If we put 2 in there, we get 2 out. So we put that in and we say that this is our gradient and our coordinates are 2 and 2. We have the gradient and the coordinate. All we need to find is the value of c. So y is equals to mx plus c. Y is going to be 2, gradient 3, x2, and c. So that will be 2 minus 6 is equal to c, which will be equal to minus 4. Therefore, our answer will be y, or if you want to write it in terms of g, that will be g of x is equal to 3x minus 4.